Okay, welcome once again to this wonderful day. Good day, everyone. For those for joining from very far place, we want to say thank you for joining. Those in Abuja, thank you. Those in various states, we say thank you for joining the day for National VEX Robotics competition. When I mean competition, I mean the online challenge training for teachers. I just want to reinforce on what our objective was or what we plan to achieve at the end of this. At the end of this training, we want to introduce students to nationwide um, to introduce students nationwide to robotics coding without requiring any physical skills. That is going to be the first step, first stage into the VEX robotics. At the end of this, we should be get ready to acquire the hardware to enable this program move seamlessly. Also going to help them build logical thinking, teamwork, problem-solving skills. And we're going to also encourage all schools to adopt STEM and robotics programs. Yes, just as we've seen in Abuja. I also want to showcase Nigeria young talent on the national platform. I know Nigerians, we are very creative, we are very hardworking to do, and we are the tech giant in Africa. Oh yes, if you have not subscribed to our channel, please do so, like and comment. And don't forget to share this with other team members, other schools, other individuals that want to be into the tech, especially in terms of robotics. So I'll quickly reinforce the rules again. I said, now this is eligible for all schools in Nigeria, either private or public schools. Now remember, as a team, you must have at least 3 to 5 students, aged from 8 down to 18, and a mentor to organize this team together. School may register for more than one team, but must be this team, and you can have multiple teams, but you have to have them in different categories. Now, the competition categories are the elementary school, we also have the middle school, and we have the high school. Then the elementary school is block-based programming, which you're going to be using the VEX Code VR, and for the middle school, you're also going to use both the VEX VR and introduce them to also Python programming. While for the high school, we will do the block programming, yes, of course. But this time around, the task is going to be difficult. It's going to require creativity, critical thinking, collaboration, even communication skills, because we need them to communicate properly. And also, at the end of the day, to learn how to code using Python programming. Okay, yeah, we shouldn't forget the key dates. This entry started from 27th of October 2025, and the deadline for submission of the project after the training should be on or before 7th December 2025. Strictly, we work with deadline, please. Winners were going to be announced at the mid December. That is going to be 2 weeks, 2 weeks into the program, and so we also encourage everybody to follow the rules strictly. And the national finals is going to be here in Abuja, 30th, sorry, 30th January 2026. While people coming from states, we've made provision that you be in Abuja by the 29th of January. That will be Thursday, and what will keep you to through Thursday down to Saturday, okay, before you return back to your precious homeland. Okay, notwithstanding, what we have today is something intriguing, something you've never seen before. Yes, of course, we mentioned STEM. What is STEM without mathematics? Okay, so what we're going to learn today, we're going to learn how to use mathematics to teach how to teach VEX using mathematical method, especially when we talk about geometrics and other form of mathematics. You can actually do simultaneous equation. Yes, of course, you can. Yeah, yeah. Oh, yeah. Someone asked about art. Yes, of course, you can also use VEX for art. We're going to be learning all of this at the end of today's courses, okay? Now, for registration purposes, right, just to reinforce, that each school must have at least 3 to 5 team members with one coach, and must strictly join the WhatsApp group for every communication. And to submit a project, you must record 2 minute uncut video that introduces what your school name, the team name, and team members, and finally why they are excited about robotics and coding. Okay, now we're also going to upload a 2 minute these videos to YouTube or Google Drive, and the link will be shared. Remember, when we said uncut video, it simply means you're going to just record the student without editing them, record your screen, and do we remember the way we showed you how to save the document? We're also going to upload those documents, so get all of this ready, get them handy, because they're going to be useful to submit a project on or before 7th December 2025. Okay, thank you very much. I don't want to keep you waiting, because it's going to be exciting, it's going to be fun, it's going to be creative, it's going to be hands-on. Okay, it's going to be hands-on, so that we don't leave you hanging. We want to teach you like we've never done before. We want to keep you on your toes while you learn. And please don't forget to ask questions, the right questions. Wherever you feel you're lacking, you can actually pause this video anytime. You can give us you can chat us through our communication channel with our WhatsApp, and tell us where you find it difficult, and we're going to assist you. Don't also forget to like, subscribe if you have not done so, and click on the notification bell so that every time we upload these videos, you'll be the first to know. So thank you. We'll call on our facilitator for today. See you soon, okay?
Okay, good morning, everyone. You are welcome to today's session, and I hope that these 3 days will be awesome, and you have been learning amazing lessons on robotics. So today we are going to be diving into a new dimension. We're going to be learning something new. We're going to be taking a new ground, and if you can, I will implore you that you follow through while I'm demonstrating. Please follow through, because I want to take it gradually, little bit by little bit. So also, if you've not commented the name of your school, you should do that immediately. Okay, so by tomorrow we are going to be sending on a platform the list of all the schools that have been participating for this for the 5 days. We're going to be posting them on a platform, so that you know that if you're part of the attendance or not. Okay, so today we're going to start a new playground. So the first thing you want to do is to click on vr.vex.com. So I'm going to do that, vr.vex.com. So this is my playground. This is my environment, and I'll just continue to free. Okay, so remember that our facilitator told us that we have a lot of things to give out throughout this competition, a lot of goodies and a lot of gifts and award. So I remember that somebody asked a question on a platform about editing a Python code. So okay, so I want to show you something. So if I click on select playground, you will notice that some of this playground are not open. As you can see, it says require VR premium license. This one says require premium license, so you can't have access to all this playground you're seeing here. And the robots there are immersive. I must tell you that they are immersive. But the ones you can have access to is from this art canvas, then downward. These are the ones you can have access to. So let me show you how the other ones look like. Let me show you how it look like. I'm going to click on select playground. As you can see that these ones are open. As you can, let me open one of it. Okay, so I'm going to open it. Let's see how the playground look like. Okay, so the reason why I could open this is because I'm using a premium license. So this is a premium license account. So you'll be able to have access to all the playground with other additional benefits that with time I'm going to tell you more about the additional benefits. Okay, so if you want to have this premium license, let me tell you how to get the premium license. The first thing you need to do is to go to File, then go to okay. So if you want to get the premium license, actually is quite expensive. It's quite expensive. So in order for you to get the premium license, you have to spend nothing less than $900, nothing less than $900 to get the premium license. But guess what? Our winners may probably go home with our premium license. That's a big thing. If you understand, that. Okay, so I want to show you that the playground. Actually want to show you the robot on the playground. And the playground has bigger robots, and these robots are real robots that can be built physically. I mean, as a matter of fact, this particular robot that I'm about to open, I've built this robot physically myself. So you can build exact robots physically, and these are the advantages of the premium license. Okay, so we're going back to our activity. So I told you that I will just run through how to save again. Peradventure you missed it yesterday. So there are two ways you are going to be saving your code. So if I have my playground being open, I'm going to the playground we used yesterday was disk mover, right? Okay, so while the playground is opening, I'll just put some code here. I'll put some code here. So let me put more code. It doesn't mean I'm not coding for any logical reason. I'm just putting things together. Don't worry, I'm just putting code together so that I will be able to show you how to save. So I have the code there. I'm going to click on. So I told you there are two ways to save. One is through share. So I'm going to click on share, and I'll be asked the name of my team. Please write the name of your team, not the name of your coach. We need the name of the team. Okay. Okay. So this is, for example, if the name of your team is GSS. Sorry, GSS. My school. Whatever the school is, write the name of your school. Then you're able to write anything you want to write about what the assignment is all about. Okay, to code whatever you want to write, to code robots that does something, whatever it is, just write it and give me a note here. For this one, I'm not going to write any note, but you may need to write notes. So I'll click on download, and once you click on download, you give it some time. You give it some time to download. So while that is downloading, if you use the share button, it will download as PDF, and the PDF contains both the code and the playground. You're able to see your code in one view, everything with both your code and your playground. So the second way, so I'll click on wait. It takes some time to download the playground. So why this is being downloaded, the second way of saving is through the file. So I'll click okay. Let me still click on wait. So the second way is through the file. Okay, it's saved successfully. So I'm going to click on open. So I'll click on open. As you can see, the name of my school is there. Code robot, whatever it is. Then the playground is disk mover, and you're going to see the playground and the date that this particular code was saved, as well as the code itself. Look at the code here. So this is the code. all the code you write, I'm going to see everything. Okay, so that's one way. The second way is through the file. You're going to click on file, then immediately click on file. It says save as. Don't do save. Save is for when you've saved before. So I'll just click on save as. Then I'm going to title it whatever you want to title it. That's GSS, my name. Sorry, I have my name already on the system, so I will say my name 2 or version 2. Okay, then I'm going to click on save. Remember, I save it in document. So this is very good, particularly in saving your code. Peradventure, you may want to come back tomorrow to have access to your code again. The first method I use through share, when you go back to it, you won't be able to import the code back to this playground or to this field here. You may not be able to import it, but through the file, you can import it. Let me show you how to do that. So you go click on file. Probably this is a new day and I want to bring back the code that I've written before. I'm going to click on open. Maybe click on open. Then in your download, just go down and look for your code. So always try to save your code in versions. Maybe today you code and tomorrow you code again. You can save it the same name but save version 2 or version 3 so that you'll be able to differentiate between, or you may probably use the dates to save it as well. So I'm going to click on open, and now immediately you open it, it will load, and you're going to see both the code and the playground load together. Okay, we didn't notice the code loaded because it's still the same interface that I am currently. So that's how to save. So while your students engage on the platform and they participate in the competition, ensure that you send us both the PDF and the file. Both method, you should send both of them to us. Okay. Also, somebody asked about the Python, about Python on the platform. So you can actually convert this code to Python. My page did not load properly. If not, I can convert it to Python. And once I convert it to Python, but I can't edit it. You can only edit the premium license. So if you don't have premium license, you may not be able to edit the Python code. But however, I can see this code I've written and I can learn the Python equivalent of this code by just opening Python. Then it's just going to show me the Python equivalent of the code. This helps you to also learn Python. Okay, so today we're going to be diving into a new playground. Okay, so I'm going to click on select playground and I will scroll down. The platform I'm going to be using today or the playground is Shape Tracer. Look at it here. The second platform, Shape Tracer. I'm going to double click on it and you allow it to load. Okay, I think I have it open here already. This is it. This is my playground. Okay, I'm going to expand it. So what's the goal today? The goal is to drive a robot around to draw the shape. We're about to draw shapes. We want to draw shapes. So the first shape we're drawing today is the triangle. We're drawing a triangle. So I told you the first thing you may want to do is to check around your field to see how your field looks like. I'm going to shrink it again and I'm going to change the camera view. So I can see the same robot that I've been using, and I can look under. I can see that my robot is the same robot that has pen under. Remember, you want to draw. You want to draw the triangle. You want to trace it. It's called Shape Tracer. So I want to trace this triangle. So who can tell me the first thing I need to do if I want to draw this triangle? Please comment. Put your comment in the comment section below. I want to know what you think should be the first thing to do. The first line of code I may want to bring in. What do you think should be the first line of code that I need to bring in? Yes, I want you to comment here. Go ahead and comment. So I'm going to expand this again. I'll change this. So look at it. Remember, I'm drawing. Yes. So the first thing I need to do, somebody say move forward. No, you don't need to move forward yet. So if I move forward, or if I drive forward, let me show you that. If I drive forward, I put this drive forward block. and I may need to determine exact distance that I need to drive. Let's say I put 400. So let's assume that I drive forward for 400. If I play this code, yeah, somebody will say, yes, this is correct, but my robot have not drawn anything one. I've not drawn anything one. My robot only moved on this line, but I've not drawn. Number two is my 400 correct? Somebody may say, yes, you are correct. But on the second thought, it's good I change my camera view and I look under it. Can you notice that my pen has not reached the whole length of that side? Okay, so that means, look at it, there's still extra space at the front. So it means that my robot, my 400 I choose, wasn't the right one. Okay, so what do I do? What do I do? I rechange. So I want someone to tell me, what do you think is the first line of code I need to bring in? Okay, remember that yesterday, and we talked about pen, bringing out pen, using pen to draw. So I'm going to start by bringing pen. So where can I find my pen? I'll find it under drawing. I'll go to drawing. Then the first thing I want to do, by default, the pen under the robot is always inward. It's not touching ground. So the first thing I want to do is to move my pen down so that my pen will be able to draw. So I'll move pen down. Then I'm refreshing I'm returning back to. Then the next thing is I want to now drive forward. So I'll drive forward. For how long? We say 400 was too small. I may decide to try 450. I may decide to try 450. Let's see if 450 will go. So I'm going to play it. And my pen actually drew now. Wow, that is awesome. So, but is my 450 correct? If you assume that is correct, we may go ahead and turn. But I may want, on the second thought, I may want to turn to see if 450 is correct. Look at my view. As you can see, my robot has not reached the let me expand it. You notice that the robot still have some way to go. So in that case, 450 wasn't the right angle, so I'm going to change it to 500. Okay, so this is more like a try and error method. So I'm going to drive it again, and it's at that 500. Don't be too sure. Go ahead and check it again. As you can see, I can see at this point that it's exactly at the edge. So that was 500. The distance was actually 500, and I'm correct at this point. So what's the next thing to do? Who can tell me the next thing to do? I want people to make comments right now. And what do you think is the next thing to do? What do you think is the next thing to do? I'll give you just some time to make your comments. What do you think is the next thing to do after driving forward? The next thing is to turn, right? So how many angles do I need to turn? That's the next question. How many angles do I need to turn? So somebody may want to do trial and error, but this is not the approach to robotics. Robotics sometimes is not about trial and error. It's about precision. It's about accuracy. It's about knowing what you are doing. So this brings us to what we call STEM technology. What's STEM technology? STEM simply means science, technology, engineering, and mathematics. In short, these days they call it STEAM, so that arts can be included. So what do I need to do? The first thing I need to know is that I'm working with a geometry. This is a triangle. The next thing I may want to ask myself, what type of triangle is this? Okay, yeah, I see people are already making comments. What kind of triangle is this? So you may want to check the triangle. Look at it carefully. You're going to notice that this is called isosceles triangle. For people that are not science inclined or that are not mathematical inclined, what is an isosceles triangle? Isosceles triangle are triangle that two sides are equal. Only two sides. Remember, triangle has three sides. Two of the three sides are equal, but the third side, thank you, somebody already answered. Thank you. That's a triangle. So that's isosceles triangle. And also, so what you need to know is that two sides are equal, and another thing is that two angles are equal. Okay, so let's take a journey to study about isosceles triangle. Okay, so I'm going to be drawing an isosceles triangle for you here. Okay, so look at it. Okay, so this is an isosceles triangle. And remember that these sides and these sides are equal. And you know that this is an angle 90 degree. And I told you that two angles are also equal. So there's mathematics that says sum of angle in a triangle equals 180 degree. Okay, sum of angle in a triangle equals 180 degrees. So remember that this is 90 and these two of them are equal. This other angle and this other angle are equal. So what do? I will say 90 plus, let's call this angle x and let's call this one x since they are the same thing. So 90 plus x equals to 180. So what do I do next? I will now say 90 plus x will be 2x equals to 180 degree. So I will say 2x is equal to 180 minus 90. So my 2x is 90 degrees. That means the two angles should give me 90 degrees together. So what do you think one will be? Definitely one of the angle is going to be 45 degrees. So x is 45. So my turning should be, this angle here should be 45 degrees and this angle here should be 45 degrees. I believe you've got that right. Okay, so while you are doing robotics, mathematics is an essential part of robotics and physics is an essential part of robotics. So you need to consider all the engineering principle while doing robotics. So we already established that one of the angle is 45 degrees. So we need to turn 45 degrees. So the next thing I need to do is what? I'll now turn right or left. Can you tell me if it's right or left? Yeah, you can actually send in the chat box. I want to know if I'm turning right or left. This time I'm turning right because my robot is going right. Okay, thank you. People are already making comments on that. Yeah, so I'm turning right, and the right should be 45 degree, right? According to what we got. So if I type 45 degree, let's see if our robot will do exactly what our robot to do. So I'll drive. Yes. Oh, no. That 45 wasn't quite okay, but we're sure about our calculation because you can never be wrong with calculation. Yeah, so that wasn't 45, that our angle was 45 degrees, but when we play our robot did not go 45 degrees. So what do we do? So let me explain another concept to you here. Okay, so let me scroll down a little. I'm going to explain another concept to you. So as you can see, if this is a robot, I'm going to draw my robot as a box. This is my robot with the tire. These are the tire of my robot. These are the tire of my robot. So my robot always is here as north and the angle here is 0. The angle here is 0. So it's more like a cardinal point. That here is 0 degree. Remember that when I say the robot should not turn, if here is 0 and my robot always, I say should turn right. Remember? So if this is 0, if I say 45 degree, my robot will just turn from here to here, like this, 45 degree, because to this place will be 90 degree. So, but what I want, what our triangle look like was like this. Triangle look like this. Pay sure you pay attention to this explanation. So our robot, look at it. Our robot was already facing up like this, and that was 0 degree. If I'm going to draw a cardinal point around this point, remember that if I draw a cardinal point, from here to here is, we know that here is 45 degree already from our calculation. So the robot will first of all turn 90 degree first, 90 degree, and we know that this is also 45 degrees. So it will be 90 with another 45 degree for our robot to face this direction. So it will be 90 plus 45. That should be the exact angle should turn. Although the angle in the triangle was 45, but we were supposed to do 90 plus 45. And if you check, 90 plus 45 should be 135 degree. So let's go back to our playground and see if 135 will give us do justice to it. So I'm going to say 135. Right? Okay. So I say turn right for 135. Let's play this again and see if our robot will actually turn. Perfect. This is perfect. This is a perfect turning. So the next thing we need to do is to drive forward. Remember I told you accuracy is the best thing to do. So I want somebody, I have a gift for somebody that will tell me how many distance I need to move. Yeah, I have a gift for a person. I'm going to give you some seconds to tell me how many distance I need to move to get to the end of the line. Yeah, I want you to make comment. I'm just going to give you a few seconds to give me how many distance I need to move. Remember that we say this is an isosceles triangle and two sides are equal. So you should be able to tell me how many distance I need to move. Okay, are you already making comments? I want to see your comments. Okay, so let's go back to our diagram while you make a comment. Let's go back to our diagram. We say this was our triangle. This was our triangle. Remember, I will say here was 500 and here was 500 because we say two sides are equal. Yeah, somebody say 700. Thank you very much. Let's see if that will be 700. Okay, so I believe that from the principle of mathematics, you know what they call Pythagoras theorem. What does it say? It says the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. Okay? Okay, somebody say right, but I want you to tell me the distance I need to move, the distance. Okay, so somebody say 700, I need more. So applying this formula will actually get you the answer. So once the hypotenuse is the side opposite of 90 degrees, the hypotenuse is the side opposite of 90 degrees, so let's put x there. So we can say s square is equal to 500 square plus 500 square. Okay, so we can now say s square is equal to 500 square should be what? 500. Please, somebody should help me with punching a calculator. Please punch a calculator for me. I want to know what 500 square is. 5 times 5 should be 25. Then 0, 0, then 0, 0. Yeah, I think so. Then plus another 500 square. Somebody say 700 again. Okay, let's see if that would be correct. Let's see if that would be correct. So 500 square times 500 square will be 25 with 0, 0, 0, 0. So we can now say our s square is equal to 250,000 plus 250,000. 25 plus 25 is 50. Then 1, 2, 3, 4. I hope I'm correct with because I'm not with calculator right now. So I hope that I'm correct with this. So the next thing I need to do is to now say my x will now be square root of 500,000. So square root of 500,000. So I will need a calculator to help me to get square root of 500,000. Okay, square root of 500,000. Yeah, is anybody helping me to do that now? I need someone to do that. I will also want to try that from my own end. So let's see, square root of 500,000. Okay, I have 707. 707.1. Okay, I'll just go with 707. So 707 is what I have. Okay, so far all the people that make comment have told me that if I move 700 it will be perfect. So let's start with your suggestion. Let's see if that will still be fine. It's possible that it's still fine. So if I press 700, let's replay our robot. Let's see if 700 is fine. Okay, that looked very good already. So I don't think I need to do the 707, but however, on the second thought, it's good we check the robot. Okay, so your guess is correct because 707, the 7 is very, very small. The additional 7, when we did our calculation, the additional 7 was quite very small that you will notice it. But if you guess like this, in some other geometry, you may not be correct. That's the funny part. But 707 was the right answer. So I'm going to give 707 there because I want to be accurate with whatever I'm doing. So I'm going to say 707. Okay, now who can tell me the next thing to do? I'm enjoying this already. Who can tell me the next thing to do? Tell me the next thing to do. Yeah, I know you are going to tell me turn. I know you are going to tell me turn, but I want you to tell me exactly the angle I need to turn. Exactly the angle I need to turn. Let me see who is going to do the calculation correctly this time. Okay, okay. Tell me exactly what angle I need to turn. Let's go back to our drawing board. Let's see how that will be. So I'm going to use this existing diagram already. I don't want to draw another one. So I'm removing the distance since we already got it correctly. So the next thing is, remember where your position of your robot is. A robot, where's my pen? Okay, my robot was facing like this already. Don't forget that my robot was facing down like this already. That's where my robot is presently, if you know. Okay, so I need to turn by how many angle? Remember, you need to draw like this. Cardinal point, this is 0. Remember, I told you the direction where the robot is facing is only 0. So, and you already know that this your angle here is 45 degree. So we have, and we also know that this other place also 45 degree. How do I know? Because 45 plus 45 is 90. This place is 90 degree. And we know that here is 90 degree as well. So 90 plus 45 will give me 135. So 90 45 give me 135 again. So 135 is the exact angle I need to turn again. So let's see if my calculation will give me correct. Okay, so let's see our comment section. I don't know, I can't see the comment now, but I think well, somebody say 135. Okay, 305. Okay, 315. Wow, 315. Okay, that's good. 315. But from my calculation, I got 135. Maybe the person just decided to mix the number together. At least there's 3, there's 1, and there's 5. So no problem. So let's see. I'm going to my own calculation. I'm going to follow my calculation. My calculation give me I should turn right for 135. So I'm going to type 135. Okay, let's try the 315, right? Let's try the 315 first. I'm not going to jump into conclusion because I did calculation. I know that calculation is always correct. I believe calculation more than guessing. But however, guessing can be correct sometimes when your calculation goes wrong. So let's try the 315. Let's see how that is going to play out. Wow, the robot is dancing a window. So dancing around and it's exactly opposite of where I need to go to. But this could be a plan too. Yeah, you may want to drive reverse this time now. Maybe that's your calculation. That's maybe correct. I told you one approach did not solve a problem. You see, I did my calculation. I got 135. This person did 315. But the approach, maybe that will be correct as well. That will be correct as well. That will be correct. Okay, so I'm going to leave the person's decision, the 315, but also know that my own say 135, but both of us are actually correct. But this time, I'm going to drive reverse. And how many distance now? Who can tell me how many distance? Who can tell me how many distance I need to drive? Yeah. Okay, so I'm going to press 5 on. Let's see if that everything work perfectly. But let me also tell you that even though the person's was correct, which one will have been a better solution? Now you have to think of a multiple solution. You have to think of multiple solution and think of the best approach to use. Yeah, you need to think of the best approach or the best solution. Remember that the person's robot remove round, and that's buy into my time if I will think in that direction also into my time. But what about if I do 135? Let's see if 135, or let's even play it with time. I'm going to play it and I'm going to see how long it takes for the robot to complete the task. Okay, that was 6.4 seconds. That was seconds, and I'm going to do 135. Remember, we have 6.4 seconds before, so I'm going to play it now. Again, using 135. Now, so sorry. This time, I'm not going to drive reverse. I'm going to drive forward. Okay, so let's play it again. Because I think in a different direction, and you can also think in a different direction. That doesn't mean that you may not be correct. It can be correct, but you have to think of optimizing your code to get a better result. So with this, that is all about drawing this shape. Okay, so we're going to pick one more shape. We're going to pick one more shape. I want you to put in the comment section which other shape you want us to go for next. Yeah, which other shape you want us to go for next. Okay, think of I'm going to go for, okay, I'm waiting. People are making comments, but I want to know which shape you want me to go for next. If not, I'm going to choose the one from my own mind. Okay, so I'm looking at this pentagon because it looks very difficult. Yeah, it looks very difficult. So I may want to choose the pentagon. That's the one exactly under my triangle. Okay, because I've done one triangle before, I may not want to do any of the triangle again. So let's return our robot back to position. As you can see, this is where my robot is. How do I start holding the pentagon? The first thing I may want to do is to click on this location icon. Please don't forget this. Click on this location icon. When you click on this location icon, we have points marked A, B, C, D, E, F, G, H, I. So these are different locations that a robot can start from potentially. So I'm going to start from D because I'm doing a pentagon, and pentagon is the D part, the shape D. So I'm going to click on D, and as you can see, my robot is now standing on the pentagon. Okay, so what's the next thing to do? What's the next thing to do? Okay, so this time I'm going to change my task a little bit. I want to draw this shape, but I want to be changing the color of all the sides. I want to change the color of all the sides. So as we already know, the first thing to do, who will tell me the first thing to do? Yeah, what do you think should be the first thing to do? Somebody will tell me drive forward again. No, that is not the first step. The first step is to bring down my pen. So I'm going to move pen down. Then what's the next thing to do after moving down my pen? Okay, I need someone to tell me what to do next after moving down my pen. Okay, so after moving down my pen, remember I told you I want all the sides to have different colors. So I prefer to change the color of my pen. Remember, by default, the color of the pen is black. So I may want to change the color of my pen. So I'll set pen color to I'm going to start with red color. Okay, so I'm changing a color. Okay, somebody say we should start with the cross. Okay, but so sorry, the cross is quite simple. As a matter of fact, you can everything just looks like 90 degrees. So, and you can actually use a loop to do the cross. So let's try the pentagon. So sorry, I didn't see your message on time. I will actually go for the cross. So I'll set pen color to red, and the first thing I may want to do is to drive forward. So up to this moment, if you've not subscribed to our channel, this is the right time to do so. You need to also like our page. That will help us to reach more audience. And also, if you've not commented the name of your school, please do that now, because it won't be fair that you attended the class and your attendance wasn't taken. So I want you to make just write down the name of your school in the comment section so that we're able to take the daily attendance. Okay, so the next thing I need to do, we say you should drive forward. For how long? For how long? For a start, you can guess any number. You can guess any number. I can guess 500. 500 may look too big. I will do 450. Let's see if 450 will work for me, because I'm comparing it to the size of the first shape I drew. This other side look a little bit shorter, so I'm going to do 450. 450 look too big. Wow. Okay, 400 should be good, but let me try 420. 420. So I'm going to give you an assignment at the end of this class. I'm going to give you an assignment. 420 look too big as well. So let me change my camera view to see. As you can see, it's supersede where I want to. So I'm going to say 410. Let's try 410. I just need to know the one of the sides. The other ones will not give issue. Okay, that looks too big again too, as you can see. So I think 400 is the exact distance I need to. So I'll drive again. Okay, that look weird. That's not correct. So let's go for 390. We'll be doing it until we get it correct. 390. Okay, that looks too big too. Okay, 380 is the right one there. That's how we'll be doing back and forth until we get that correct. That it look correct now. Oh, no, not yet. Look at it. That is too much. So 370. Let me go for 370. 370. I believe that you're already catching fun with this already. Okay, 370 seems better, but I may also want to try 360. Let me see between 360 and 370. Let me see which one is better. 360. Okay, somebody say 350. Okay, 350. We're going to try 350. After I try 360, I'll try 350. Okay. I think my 360 look okay, but I won't just take my word for it. Let's try 350. Let's try 350. Let's see if that will give me what I want as well. Okay, let me change the camera view. And 350 is accurate. Thank you so much. You are correct. 350 is a better option for me. So I'm going with 350. So what do you think is the next thing to do? I want to say, oh, get this right. This one. Let me see who is going to get this correct. What is the angle for turning? Okay, this is going to be fun. Let me see who is going to get this correctly. Tell me the angle for turning. Remember, you need to go to your drawing board. You need to do some calculation. Okay, so I will have difficulty in drawing that shape, pentagon. Let me see, where can I get this shape? Can I get pentagon already? I think the shape. Okay, let me go with this. The pentagon, and I want to remove the fill. I don't want any color inside, and the outline I want to make it thick. The width, let me change the width to something that's a little bit thick. Okay, so as you can see, this is my pentagon, but it's not exactly like the playground. As you can see, the playground is like this, so I need to turn it. So I'm going to turn it. I think this is how my pentagon look like. Okay, so yeah, this I look like. So remember that my robot at this point, my robot is already here. So I think my robot is already facing here like this. I remember that this is 0. So the first thing I need to know is the angle here. I need to find the angle here. So who can tell me the angle? Yeah, somebody is making comment. I need to know. Yeah, I want to know exact angle that I need to get. 45 degree. Okay, thank you. Somebody say 45. I think we have mathematics guru in this place. Mathematics guru are here. So I'm going to show you a concept that I can use. There's a formula in mathematics that says sum of angles, sum of interior angles, sorry, sum of interior, let me write here, interior angle of a polygon is n minus 2, 180. Okay, n minus 2, 180. And there's another formula that says that 1 interior plus 1 exterior is equal to 180. And there's another one that says 1 exterior is equal to 360 over n. So I'm going to start by using the last formula. I want to know what one exterior angle is. So one exterior is equal to 360 divided by how many sides is 5. So finally, I'm going to do 360 divided by 5. Let me try that with my calculator. 360 divided by 5, I get 72 degrees. So 72 degrees. Okay, remember that when we say 72 degrees one exterior, we're talking about this angle here actually is the one exterior. This exterior is 72. This is 72 degrees. So I believe that when I turn 72 degrees, I will be perfect. I'll get that. So I've given you 3 formulas. You should know that the last one is the right one to use. So I'm going to put turn right for 72 degrees. I'm going to write 72 degrees. Although somebody gave me 45 degrees, I will try your 45 degrees. I think I should try that first. 45 degrees. Let's see if that will be correct. Okay, that look nice, but let me use my camera to see. That look okay. It look okay, but it's until when you want to drive forward. Now let's see, drive forward, and remember we now have our distance because the regular polygon, all the sides are the same. So I'm going to do 350. So let's play it. Let's see if our robot will go in the right direction. Wow, can you see that that did not go quite well? So I'm going to change back to 72. I'm going to play it again. This looks perfect. Okay, now what do I need to do? I need to drive. I need to also turn again. How many angles do I need to turn again? Okay, I may want to put my code in a repeat. Let's see if that will work for me. So I'm going to I will have used but I'll just use red pen all through. So let's say you should repeat this thing. Let's just say 5 times. Let's see what this will give us. Let's see if that will work or not. If it not work, then we're going to change our approach. Let's see. That did not work. However, it's going to draw it for us, but there's a problem somewhere. Okay, that actually draw the shape for us because I've seen it ahead that it's going to draw for us. But let me remove this. Let's see. I think that this last code was the one that gave issue to what we did. Can you see that I do not need to stress myself over anything? Just a simple repeat block can help you to repeat. So before you start any program, make sure you see if there's any repetition of what you need to do. Then approach your project with a pre-plan of how you want your code to go. And also, before I step out, ensure that you also know that mathematics, physics, chemistry, all sciences, including engineering, are integral parts of robotics. Robotics stand on the wing of STEM. Without STEM, you may not be able to do robotics because robotics is what encapsulates every part of STEM into one. So thank you very much for attending to this class. At this point, I'm going to hand over to our next our coordinator. So before that time, I want to give you an assignment. Okay, so the assignment is to draw the cross. Okay, because somebody wants us to do cross, so make sure you do the cross and have a beautiful day. Bye.
Okay. Thank you for staying up to this time. Isn't the class exciting as I promised? Is the class fun? Yes. Yeah. While the class was going on, I just saw a lot of possibilities lot of ways of how I can actually use this to teach in my classroom. For someone having difficulties with understanding mathematics and loves playing games, don't you think this could be another exciting way of teaching that kid? Okay, that child, that particular child that always want to learn but in a fun way. I think this is the best opportunity for you to teach them and let them learn perfectly. Yes, once again, I remain your anchor for today. My name is Ihem the Zemeka. Thank you for waiting up to this day. Please know that tomorrow, which is supposed to be the final day, we are going to share a lot of information. Please, let's come online. Let's be active. Let's tell those that have not those that have that couldn't meet this opportunity to please find time to go through the YouTube channel. We're going to be leaving it open, and the form yet is still open. But at the end of the whole of the program, we'll shut it down and we'll focus it on states because some states have reached out to us that they have having challenges, especially in the training. For a place like what's it called, Ogun State, they have reached out, and one other state, Nasarawa, right? And we still need to help them achieve this success. So please, if you're finding it difficult to join, to learn, to practice, please don't forget to engage us on our WhatsApp group. We have tutors, we have professionals waiting to explain more for you. And of course, this is a fun way to carry a class of 100 students. Now let's imagine you don't have this robot, but you have all of this. Now this is just for mathematics alone, and we have not even done the arts. Let's say you want to turn this into a beautiful house. You know, with these shapes, you can actually make a beautiful home. You can make designs that professionals see and they can even want to pay for it. So this can also be used to teach shadings and different forms of teaching. Okay, so I want you to understand that in teaching that is practice able, teaching that is hands-on, teaching that is engaging is the kind of teaching this child want to get himself or herself involved with. So be that wonderful teacher today. Do what is best for your class by introducing VEX Robotics. Remember the platform is still vr.vex.com. I'll repeat again, www.vr.vex.com. We're opening a channel to receive your comments, contributions, and of course, feel free to criticize where you don't like, drop in the chat a comment. We are going to look at it for improvement. We think all criticism very important to us, so we don't discriminate. So go ahead, drop your comment, say how we can improve this, how we can make this better. Yes, most of you have raised concern about um, this hour, the hour the class is going on. But we fully understand that this hour may not be convenient for you. But remember, as I said earlier, our partners, international partners, are currently watching. So we need to do this at this time for your conveniences. So that's why it's on YouTube. You can watch your own particular time, take your time, watch and learn properly. Then ask questions. We're going to assist you. Once again, I say thank you for joining. We're going to be seeing you tomorrow. Tomorrow is going to be the grand finale. We're open to a lot of questions. You can start typing your questions now on the WhatsApp group. We'll compile them, and tomorrow we're going to answer all of the questions. We're going to tell you all the modalities for the for submission for the program. We're going to give you everything that is needed for you to conclude this class. So don't forget to subscribe before you leave. Don't forget to like. Don't forget to share and leave your comment on the comment section. We say thank you once again. We also want to say appreciation. We also want to give a big appreciation to VEX, who have given us the platform to empower Nigeria, and the FCT-SEB, who has also made it possible for all of you to be part of this training. Of course, the Ministry of Education won't forget about them. They are, we give them big thumbs up, and we say big thank you to all of you. We treasure this and we won't take it for granted. So thank you. Do have a nice day ahead. Bye bye.